This is Catherine Schmer, and in this video we'll talk about graphing polar equations. In the last section we talked about the relationship between polar coordinates and Cartesian coordinates, and now we want to do some graphing in polar. Just as when we were learning to graph equations in x and y, a table of values is often the best method for graphing by hand. We can also use our calculators for assistance. I'm not going to actually demonstrate a particular calculator in this video because I know that you're all using different ones. Some of you are using the TI-84, some of you are using the 89, and some of you are using the Inspire, and all three of those graph a little differently. But some of the tips for graphing in polar, under the mode setting of your calculator, you want to make sure that you've selected radians and polar because most of our polar equations will be utilizing radians as opposed to degrees. Also, when graphing, you want to start with the standard window and adjust as needed. So sometimes the problem becomes, what angles should I use as my lower bound for the angle and upper bound for the angle? If you start with the standard window, that will give you an idea of the graph, and then you can adjust, you can zoom in or zoom out as necessary using your window feature. So here is our example. We want to complete the table of values below and use it to graph the equation r equals 6 sine of 2 theta. Then check your graph using the calculator. So basically I have a bunch of theta values, 0, pi over 6, pi over 4, pi over 3, pi over 2, etc. And I want to plug each one of those into my r function. So when theta equals 0, I'm going to have r equals 6 sine of 0, and we know that that is equal to 0. So I'm going to put a 0 in my table for r. When theta is pi over 6, I'm going to have r equals 6 sine of 2 times pi over 6, which when I put that in my calculator, I get 5.2. Now it's really important that you're in radian mode, otherwise you'll get some wacky answer. And we're going to go ahead and give the decimal rounded to the nearest tenth because we're just trying to get a point on our graph. So pi over 6 and r equals 5.2. When theta is pi over 4, I plug that into my equation, so r equals 6 sine of 2 times pi over 4, which is 6. So I put that in my table. And I keep plugging in each angle until I completely filled in the table. So I get pi over 3 and 5.2, pi over 2 and 0, 2 pi over 3, negative 5.2, 3 pi over 4 and negative 6, 5 pi over 6 and negative 5.2, pi and 0, 7 pi over 6 and 5.2, 5 pi over 4 and 6, 4 pi over 3 and 5.2, 3 pi over 2 and 0, 5 pi over 3 and negative 5.2, 7 pi over 4 and negative 6, and 11 pi over 6 and negative 5.2. So notice that some of my r values are negative, so I'll actually be going in the opposite direction from the angle that I'm given. So now let's number these so that they're easy to keep track of on our graph. So I'm going to number these 1 through 16, starting with the 0, 0 as 1, and then just going in order as my angles go around the unit circle counterclockwise. Okay, so using these points, I want to graph them on the grid. So my first point is 0, 0, so I'm going to make a point at the origin. My second point is pi over 6 and r equals 5.2. So along the line that is representing the pi over 6 angle, I'm going to count out on my circles until I am 5.2 away from the origin. So a distance of 5.2 from the origin on the pi over 6 angle line. So I make a point, and remember we numbered our points. That's point number 2 in our table. Now point number 3 is pi over 4 and r equals 6. So I'll go ahead and plot that point, and then pi over 3 and 5.2, and then at pi over 2 I'm back to 0. So that makes one complete loop in my graph. And hopefully you've looked in your calculator and have an idea of what this looks like already. But I get what looks like the petal of a flower. And we actually call this in polar coordinates, this particular equation is called a rose, and this is called one leaf of the rose. So let's keep going with plotting our points. So our next point after being at the origin again, so point number 6 is 2 pi over 3 and negative 5.2. So the 2 pi over 3 angle is in the second quadrant, but because I have a negative r, I'm going to pop down to the fourth quadrant, and my point number 6 is 5.2 from the origin in the fourth quadrant. Point number 7 is 3 pi over 4 and negative 6, again in the fourth quadrant because I'm going the opposite direction along that 3 pi over 4 angle. And then point number 8, I connect all of them and I get a second petal or second leaf of my rose down in the fourth quadrant. And now I continue this. My points 10, 11, and 12 are in the third quadrant. Connect them and get my third leaf of my rose. And then the angles that are remaining are all in the fourth quadrant, but because the r values are negative, that brings all the points up into the second quadrant. So that gives me the fourth leaf of my rose. So I have each leaf of the rose, one in each quadrant in this case, and the center of the leaf being along that pi over 4 bisecting line of the quadrant. So that's how we graph a function in 3 dimensions, or in polar coordinates.